Hello and welcome to a buildingSMART webinar. This webinar is part of the buildingSMART Virtual Summit for Spring 2022. Thank you for joining us today. My name is John Proctor and I will be your moderator. Details of today's webinar are on the screen. This is the third session from the building room. The topic of today's presentations are openBIM and energy performance for historical buildings. We will be hearing from a variety of colleagues from buildingSMART Italy, Anna Moreno, the president of buildingSMART Italy, Elena Gigliarelli, and Anna Ferreiro. The webinar is scheduled to last for an hour and a half with a short question and answer session at the end. The webinar is being recorded and will be made available in the replay section of the event within the next 24 hours. Before I hand over to our speakers, I'd like to remind you that your phone lines will remain muted for the duration of the webinar. If you have any questions or wish to make comments, please use the comments box in the control panel on the right-hand side of your screen. So, please add any comments, which we'll take at the end in the comments box. I'd also like to bring to your attention the information that is on the screen now. buildingSMART is committed to ensuring that participation in the development of standards is unrestricted, the process for their adoption is transparent, and that standards that are developed do not favour any particular provider, but are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. Now, I'd like to hand over to Anna, who will start the presentation. Thank you.
My name is Anna Moreno and I am the president of the Italian chapter. In my presentation, I will speak about the importance of conceiving the cultural heritage as a living being, the generation of information during the centuries, the use of BIM for energy performance contracting and to improve the energy performance during the lifetime of a building, what information is exchanged when, why, and among which actor, and finally the guidelines on energy performance and BIM. The buildings are living beings and we need to take care of them during their lifetime, which lasts decades, centuries, even forever. Here are some examples of buildings that changed their use during the centuries. On the left you see a Cappuccino convent transformed in the headquarters of a state advocacy general in the middle of Rome. On the right, a rural facility transformed in a luxury home. On the left, a monastery with Roman cistern transformed in hotel with spa, and on the right, an ancient hospital transformed in a museum of medicine. In the picture, you see the magnificent autopsy room. A building may have been conceived and built in the Middle Ages, then be adapted in the Renaissance, and nowadays may need a change of use or energy requalification. But even more modern buildings that were built 20-30 years ago may need renovation. All the information that can be collected from what exists, if available, will be in analogical format, and in any case it will not directly be processable by software. Therefore, the BIM for existing building means, first of all, to collect the information in a systematic way, to verify its correspondence with the reality, and then to make informed decisions based on simulation obtainable with software. European directives on energy performance require the refurbishment of at least 3% of the state buildings, and many of these buildings are listed. It is possible in these cases to use APC if the investment can be recovered in 10 to 20 years. However, existing buildings refurbishment needs to consider different constraints such as compliance with urban planning, safety securities, architectural barriers, restoration rules, and need to ensure the functional use of the different zones with the right lighting and comfort, and of course the reduction of natural resources. The benefits are not only the reduction of the costs for the use of natural resources, but also better health due to a better comfort, lower management costs due to the possibility of the use of BIM to monitor the HVAC systems, and above all the reduction of the maintenance costs, which has the greatest impact on the management of the building. The use of BIM for energy performance contracting is a means to build a trustful balance between the achievable saving and investment value because it is based on reliable data. The point of cloud can provide a very faithful geometrical information, while other advanced techniques can provide the exact position of the different HVAC systems. On this basis, the evaluation of different scenarios can be made and reliable computational data can be obtained through BIM 4D and BIM 5D for the evaluation of time and costs. This is very important for the owner that can make informed decisions. BIM is always important when looking at the entire life cycle, as we know that the building sector is one of the highest impact on the environment because of the continuous use of the soil, emission deriving by the material used, emission during the construction, and above all emissions during the use. Through an extended use of BIM, it's possible to reduce the impact of the built environment because we can make the refurbishment of existing building more than build ex novo. Reuse or recycling the materials or use low impact materials. Optimize the logistics in order to reduce the waste in the building site, and build and restore to obtain zero energy buildings. It has been evaluated that if we look at the entire life cycle of a building, only 5% of the cost is related to the design, 18% to the construction, while more than 70% is related to the use of building. Therefore, a small mistake in the design due to wrong assumption will be paid for the rest of the life of the building. The European Commission has published the result of an investigation that has shown that there is a huge gap between the energy performance that has been considered during the design, what has been obtained during the construction, and what is the real performance during the use. That's why it's very important to provide simulation with trustful data using BIM and have a monitoring system using digital twin to monitor the behavior of both occupants and equipment. The reason for the energy gap is related to the management of information during the life cycle of the asset. In the left side, you see the degradation of information concerning both the geometric model, the technical data, and other general documents such as authorization documents of the asset. You can see how already today it is possible with an existing asset to give back value to information through a correct definition of the asset information requirements and exchange information requirements during the redevelopment phase. In the figure on the right, you can see how information management is constantly growing using BIM, while without BIM there is a substantial loss of information passing from one phase of the asset lifecycle to another. In the next slide, we will see which information is exchanged and among which actor during the building life cycle. The existing condition analysis is the most important phase for the refurbishment of an existing building. Any euro spent in this phase to obtain trustful information is paid back of at least one order of magnitude during the next stage of the building lifetime, especially during the operation management. The focus in this phase is in fact on the exchange and the sharing of information among the different actors. During the existing condition analysis, it is important that the regulating authority provides the plans and eventually the history of the previous refurbishment. Besides, provide the requirements for energy performance, health and safety. The owner provides the use profile of each thermal zone, any refurbishment work done previously, the electricity bills of at least 3-5 years, the plant of the HVAC system, if existing, etc. The architect in charge collects all the information and starts to build the digital model of the asset, verify the information received, and eventually use advanced techniques such as laser scanning, thermography, etc. to build the digital model. The BIM Building Energy Model Consultant makes a first diagnosis and evaluates the energy class of the building. It can also produce a preliminary simulation of some intervention to improve the energy class of the building. The map engineers intervene to provide advice on the facility of upgrading and or revamping or substituting existing HVAC systems. At this point, the architect will have all the elements to prepare the preliminary design of the refurbishment as shown in the next process. The McLemming curve on the left shows how important it is in this phase in order to reduce the time and the cost. In practice, we are moving in the beginning of the building process, the decision-making process, when we are still in a virtual world, green shape, when every variation costs a few days or hours of work instead of being obliged to stop the work to solve unpredictable problems deriving from wrong assumption, gray shape. The use of BIM will allow to achieve better results in less time and minor cost, and possibly without legal dispute, which is the red shape on the right side. During the preliminary design, the ESCO or financial institution providing the loan will have the role to make the financial evaluation of the intervention and compare with the possible achievable savings. With the use of BIM collaborative format, all the actors will contribute to find the best technical solution for the best performance and the minimum costs. Thanks to BIM and the information collected during the preliminary analysis, this process will be very interactive and fast. The main output of the developed design phase will be a more detailed refurbishment plan that will leave less room to mistakes due to incomprehension and or design errors as a consequence of interference between architectural and HVAC plans. During the technical design, all the choices will be frozen so that the financial plan will be even more detailed. The model of the refurbished asset will be enriched with all the information related to products and equipment that will be used during the construction phase. This model will be the base of the contract with the constructor. The construction phase is the most challenging. Usually, constructors are not very digitalized and they interpret the design more than executing what have been decided in the technical design phase. It is therefore important that the constructor knows how to read a BIM model, and if any modification occurs, he promptly communicates it to the owner architect in order to have a real digital twin of the building. In this phase, the role of installers is important too, as they need to provide in a digital standardized format all the information needed to manage and maintain the installed equipment, and also information on the final disposal. We know how costly is the maintenance when any information about the equipment is missing or not updated. If everything has been realized as described, the operation and management will be very smooth, as anybody involved in the management and maintenance will find all the information in the right format whenever needed, and even after years the refurbishment has been completed. What I have presented is better explained in a guideline that can be freely downloaded from the Italian buildingSMART chapter website. Here is the link. This guideline can be considered the body of knowledge for the qualification on the use of BIM for energy performance that I will present later. Here are my contacts, our website, and we will be happy to reply to any question later on.
That was great. Thank you, Anna. Very interesting presentation. As Anna said, she'll be rejoining us for item 4 on the agenda a little bit later, building information management for efficient energy renovation. I'd now like to invite Elena Gigliarelli to join us. Hello, Elena.
Hello. Hello.
Hiya. If you would like to share your slides, Elena, share
Yes,
your screen.
Okay. I hope that
Yep, just bringing
will
those on
work.
screen.
Can you see my
Yeah,
screen?
we can see them on your full screen, so please go ahead.
Great. Good morning to you all, and thanks for the opportunity to participate in this prestigious event facing very important critical issues. Today I will speak about the BEEP project. BEEP project is the acronym of BIM for energy efficiency in the public sector. As a successful case, able to enhance the capacity of public local administration to design and realize innovative energy environmental improvement on historical public buildings throughout a multidisciplinary and integrated digital approach. The topics I will talk about will be a brief introduction, very brief, of my institution, the definition of contents, the challenges of the project, the Italian, just review, fast review of the partner case studies, and the main results of the project. My name is Elena Gigliarelli. Gigliarelli is complicated to pronounce. I'm sorry for this. I'm Italian architect and researcher at the Institute of Heritage Science of the National Council Research of Italy. It is an interdisciplinary institute whose mission is to pursue scientific excellence and encourage innovation in the knowledge, conservation, and use of cultural heritage through collaborative research involving humanities, experimental sciences, technological applications. This is the Built Heritage and Knowledge Lab that I lead. It's a laboratory open to research with different backgrounds to improve the knowledge and conservation of built heritage by innovating analysis and intervention procedures throughout ICT methodology integration. This is the team is composed mainly by architect and engineering. The BH Lab is currently engaged in numerous research projects, both at national and European level, activities addressing key topics for innovation or refunctionalization process of the built heritage, and for the fights against climate change within an integrated and sustainable conservation approach of building and urban areas. Coming back to the big project, the project is financed by the European program ENICBCMed European project, which is the largest cross-border cooperation initiative implemented under the umbrella of the neighborhood instrument. The objectives of this instrument are the consolidation of the relationship between bordering countries by enhancing social and economic development, also throughout environmental challenges. That is the priority faced by BEEP project. This is a consortium. It's made up of 8 partners out of seven countries of the Med area. 3 of them are European, the ICPC-ECNR, Minuti Associati, Istituto Valenciano della Edificazione, and the Cyprus Institute. The 4th are non-European of the Southeast Mediterranean, the Egypt-Japan University and Science Technology, the Royal Scientific Society of Jordan, the Center of Cultural Heritage Preservation of Palestine, and the Lebanese Center of Energy Conservation. In this way, we could test these emerging technologies in 8 different countries to demonstrate its scalability to the entire building stocks of the Mediterranean area. Our project tackles 5 main issues and challenges. The leitmotif is the approach to energy efficiency of the historical public heritage by the use of strong digitalization of design and decision support tools. The framework of the project. Despite European Union was an early mover of the climate change adaptation and mitigation policies, still a coordination action to the built heritage is lacking. Under the momentum of the European Green Deal, the Climate Heritage Network, led by Europa Nostra, have recently published the European Cultural Heritage Green Paper, in which heritage is finally framed in its dimension as a key resource and a driver for the fight against climate change. I just want to remember that Securba was on one of the first European projects that was dealing in this sense and was coordinated for Italy from my institute. Why the choice of heritage? BIM. BIM for us represents one of the most interesting lines of research for the digital management of the knowledge that have been produced during the conservation process on architectural heritage, as well as the building performance simulation that allows the study, the optimization of energy performance in interrelated way, by the way of the creation of behavioral model of historical manufacts, and all of its components, right, as well as the envelope, the technical system, the occupier behavior. Like BIM, building performance simulations involve a simulative approach, but in a different way. Building numerical simulation can be attributed to the category of non-destructive analysis and are particularly interesting tools to support the conservation process in historic buildings. The fourth themes is the interoperability between the two simulation environments, HBIM and BIM performance simulation. Although HBIM model already contains a large part of the data required for simulation interoperability, saving time and costs by reducing the risk of errors, the data transfer is not very efficient, especially on historic buildings. The transfer takes place mainly throughout two open files formats that are IFC that we know, and green building essential markup language GB XML format. The interoperability problems concerned the data re-input, the lack of data exchange between the two environments, errors in the geometry, and data transfer loss of active parametric link between the two environments. In the end, either the BIM model isn't BIM anymore when you transfer to the simulation, or the simulation starts from the scratch, meaning the loss of one of the main benefits of BIM. Then there is a last but very important tool that Anna also described in the previous presentation. That is a tool that provides public administration and is a powerful method for the energy to realize this intervention, because provides private funds for the interventions. This diagram represents the workflow of the project and underlines the centralities of the HBIM platform for all the series of surveys, analysis, simulations that we developed that are necessary for the design solutions. I will briefly go further on this schedule because Anna has already showed the process, and we are performing this process with EBME. So just let me go further on. That is interesting because we apply these in a concrete case studies that I will show after in a brief way. Okay, so this is the Italian case study. It is a very prestigious and important building. It was started and it is located in the Renaissance center of Rome. It is owned by the state property, so it is a public building, and it is currently the seat of the state advocacy. The first activities that we perform regard historical and architectural analysis that is essential for the knowledge of the building. It's also a starting point for all the other in-depth analysis. Then we start with the geometric survey of the buildings that was created, integrated different technologies For outdoors, we use the laser scanners, the photogrammetry, and for indoors, the simultaneous localization and mapping. That is a particularly suitable tool for survey the interiors of large buildings because it has a great rapidity of acquisition. The photogrammetry allows, because it's it has a great details, allows the facilitate the conservation state analysis, including the description of materials and the decay and the deterioration patterns that you can see here representing thematic maps. Then we perform a set of energy environmental analysis, starting from thermographic surveys with the aim of getting information on the external and internal walls of the buildings. This was the base for the identification of the wall stratigraphy that have been combined with the consultation of traditional architectural manuals. The thermographic analysis have allowed also to identify more recent interventional transformations undergone over the time, as well as confirmation problems such as thermal bridges, air cracks, matters emissivity, capillary rise of water, irregularities and degradation in the internal layers. We perform also a set of energy. This analysis made possible to identify the measurement points for the thermofluidic matrix analysis. For an optimized planning of the positioning of the measurement point of a heat flow analysis, we perform an additional numerical simulation of the sunshine hours of the building during the winter months. For the simulation, we use the combination of Rhinoceros software with Grasshopper and Ladybug environmental analysis plugin. At the same time, we also carried out the analysis of indoor microclimate, providing useful data for the calibration of the building dynamic simulation model. Here we can see the energy efficiency we can see a phase of the energy efficiency building information model. There was the next step of the project. This is a centralized repository to optimize the management of the large amount of the information deriving from the different analyses that we carried out. We have already, as we have already seen in the process flow schema, the World BIM Consortium performed a feasibility study on the interoperability between the different combination of software depending on the country-specific context, also for a regulation point of view, and on a larger skills available. Italy, for example, opted for a simplified dynamic calculation method following the ISO 52016 regulation. It's in the annex, but the other parts choose for different combination that we can see after. The interoperability studies aim to find a balance between BIM and energy modeling that can reduce parallel operation at the risk of errors in data passage while keeping the model consistent. The other aspect is to keep, also thanks to clear definition the model uses, as much as possible every expert involved within its disciplinary comfort zone. And this is the interactive process that is followed by the expert involved from the first phase of the building, a shared knowledge framework to the design of the data flow to the interactive process of the modeling, export, control, import, and final control. which, depending on the expert and software involved, may also include the deep well expert who specializes in landing interrupted streams. In the Italian case study, the activities involved, of course, in here we have the coordinator, Minucci associate, and the developers of the energy analysis software, Logical Soft, which and the process is divided in 3 main phases. The first is the construction of the shared knowledge framework and data flow, planning among the experts involved, were then consolidated with a test on simplified models to identify and address general interoperability problems that are a test on portion of the case study representative of the specific problem of the case study. A lot of problems that can be that we address. And then full modeling of the building with a final interoperability checks on the entire quality of BIM objects to be imported, supported by Archicad thermal modeling protocol developed in the previous 2 phases. Here you can see the video that represents the final HBIM model built on the basis of the modeling protocol that was run by the group and which was assembled, embedded into an entire process guideline, including all the software combination, of which we have already published parts as a deliverable, and which is one of the guiding the World Consortium dealing with the various case studies. After a post-processing phase, however, required by the workflow, we write at the final geometric model with the thermal log with its definite stratigraphies. The thermal zones were then modeled with the eye to the European legislation, which imposed particular constraints, and all the plans engineering part of the actual calibration process. So, the results of this analysis and simulation led to the definition of a performance-based design workflow that consider the criteria of compatibility with the heritage significance of the building, efficient economic environmental sustainability, in order to obtain the most efficient retrofit solution. In this case, you can see the photovoltaic panels in the buildings. I will briefly show the other part of the study. In Cyprus, the British Cavalry Club is a listed building rich of heritage significance that will host the new Focal Museum of Nicosia. The Cyprus partners use Design Builder. This is a user-friendly modeling environment for energy plus software tool developed to ease the building simulation process. The Spanish case study is the Palacio de Catalunya in Valencia, Spain. The activities in Jordan includes the study of the Al Karak municipality guest house. This is a municipal building that, like most of the Jordan buildings regarding energy efficiency and thermal comfort, has a very poor performance. These are the results of the scenario simulations. This project is considered the first of its kind in Jordan regarding objective and outcomes. Throughout this project, we have produced the first ever officially signed BIM execution plan in Jordan. In Egypt, we have 2 case studies. Both are in the old city center of Alexandria. Here you can see the Kordai buildings and the process from the large scale survey, the BIM modeling, till the energy simulation. And the Horea Center for Creativity also here. The process of scan to BIM process and Revit to design builder that have been performed. The measures for energy innovation of the part of BIM in all countries were mainly of two types. As passive measures, the most used by the partners in the retrofit scenarios have been the incorporation of thermal insulation from inside of the building and the incorporating of shading system. As in active measures, the most popular of the renovation of, are the renovation of the lighting with the LED lamps, the replacement of heating and air conditioning equipment, with the efficient ones, and the incorporating of building management system, which is a very important tool. Regarding the implementation of the novel energy sources, many of the partners with our indications have adopted for the installation of photovoltaic panels on the roof, but using them as the heart, as a new situation and areas for social activities. Lebanon also dealt with two case studies, Rahid Karani Cultural Centers in Tripoli and the municipality of Tripoli. I will go further now. This is Palestinian case study, the Marcus Nassar Palace. The Center for Cultural Heritage Presentation is a big partner, has a great heritage skill with heritage conservation, but they had never dealt with other issues, energy efficiency, for built energy or BIM. So they acquired experience and skills during the life of the project. So, in conclusion, I can say that the BEEP project main results was the establish of a common framework among the partners to set up and harmonize the project workflow depending on local specificities. Furthermore, we have not only reached but even exceed the performance indicators of the program requested in terms of carbon dioxide avoid, kilowatt-hour renewable energy source produced and self-consumed. So we are very satisfied with the results, but we are not ending the project. Now we are supporting the public administration, be the owners, managers, in the renovation project, for the renovation project, and with the energy performance contract implementation phase, in helping them to write and sign the correct and more suitable contract for efficient ESCO. Thanks to all for your attention.
Thank you, Elena. That was an excellent presentation. Really interesting to hear about the BEEP project. Particularly good to see the many examples and case studies that you were able to present. So thank you for that. There is a question that came in from Stefan Joud. We'll deal with it at the end, but if you could take a look at it in the comments during the rest of the presentation, then we'll come back to it then. Thank you.
I can
I'd like to invite... Yes, that you can. I'd like to invite Anne Ferreiro to join us on stage. If you want to turn on your camera, Anne, thank you. And I will bring up your slides. And Elena, you can stop your camera at this point, if that's okay. There are your slides. If you want to go full screen, please go ahead, Anne.
I'm an architect and I work as a product designer and project manager at SIPE. SIPE is a company of software for architecture, engineering, and construction. If you don't know us, we've been developing software for more than 40 years now. First, I want to say that your presentation, Elena, was really interesting because we have some points in common that I'm going to explain now. First of all, I'm here on behalf of BIMSPEED project. Okay, BIMSPEED project is a project that aims to address the challenge of renovation, combining tools and methodologies. Okay, all based in BIM or building information modeling. What we want to do now is to address all these buildings that need to be renovated in Europe, including historical buildings. I'm going to show you later or demo cases. And the idea is that this model could be the catalyst for smarter, more efficient, and deep renovations of residential building sector. Right now, we are not as far as the other project that we saw before. We are right now developing the demos, okay? So I will not be able to show as much information as Elena, but still it's really interesting. BIMSPEED project is based in a platform, and the idea for this platform is that this platform will be capable of, or is capable of providing a collection of tools and services all related to renovation, from point clouds to the program that I'm going to show you today, because I think, well, it's the part that we have developed and the part that we are really interested on. You can get access to the platform from the BIMSPEED webpage, and I encourage you to go there. Also, because there's already a lot of tools connected, including the one that I'm going to show you today. And I think there's around 30 tools. And for us, this is really exciting because, at least from my experience, is one of the times that more tools has been connected to the same platform or related to the subject of energy efficiency and renovation. The tool that I'm going to speak today is called openBIM Analytical Model. And what this tool does is it tries to solves the problem that Elena was talking about, this problem about interoperability. I'm gonna show you now. I want to go really quick to show you the demo buildings that we have. That I didn't have them on the presentation. They are on all these countries, and I will say that some of them are just all buildings, no? BIMSPEED project is based in residential buildings, okay? So some of them are more regular buildings, more 50s, 60s buildings, but some of them are historical. As you can see, this one that we have in Varna in Bulgaria, or this one in Italy that is from the 17th century. So just to show you how all the buildings that we have, as you see, we have some different building types and epochs, and one challenge for us was to address all these types of buildings, okay? Including the historical ones, maybe one of the most difficult ones. Going back to the presentation and going deeply in the tool that we have developed, this openBIM analytical model, okay? What we wanted to solve, or we detected mainly two problems in this workflow, no? How to make the energy simulation of a historical building or a refurbished building. The first one was the complexity, no? The complexity of the buildings itself, sometimes only because of decoration, no? When at the end you have these energy plus engines or DOE, etc., that work with really simple models. This is one of the problems we wanted to address. The other one, of course, as Elena has said, is the interoperability. Okay, right now we have a lot of tools to design the BIM model, starting with Revit, but we have Allplan, Archicad. We ourselves have a free tool to build BIM models. And these tools are kind of isolated, no? They are doing their own, and that's a problem. And then we have these engines. There are other Energy Plus that we currently work in SciP with Energy Plus, but there are other engines as DOE, etc., that are actually also isolated between themselves, but isolated from the new BIM modelers. Well, no, they are not new, but okay. So what was a little bit, these were the two things that we have a problem with, let's say the complexity and the interoperability. And then we have defined a workflow, really simple workflow. The first will be to create this BIM model and be capable of importing them correctly, okay? Then the second topic was like how with these imported BIM models, we create a highly accurate energy model, meaning a model that can be inputted in simulation engines. And then, well, the third topic was how we import or export all this data again to the BIMSPEED platform, okay? So basically, how we approached this problem is that in one hand, we have the architectural model. This model is composed by walls, is composed by slabs, by windows, by doors, etc., etc. Is what we call here in SciP a model of solids, okay? And then we had the analytical model. This model, that is the model that is used by the engines, is composed by surfaces, by edges, by boundaries. Is what we call, or what it is a geometrical model. No, so we had these two models, no, one in front of the other one, and they were trying to fight, no, to get to the energy simulation. So what we did is what we always do when we have a problem in SciP is that put it in another box, okay? Separate it from the architectural modelers and separate it from the simulation engines, okay? We are going to solve this problem in a separated box or separated program. We created this openBIM analytical model. And the idea for this model is that this model will follow these steps, okay? That these topics. First, you create architectural model, and this architectural model is going to send the information to openBIM analytical model in IFC standardized format. I'm going to say that it's really important that its spaces are defined in this model, because without the spaces, an openBIM analytical model will not be capable of creating this geometrical model. And then when we create this geometrical model, we send this information. Right now we are sending it in JSON. It was interesting to see that you send the information in XML in the other project, but we are using a JSON file right now to input this information in our tool SciP term that works with Energy Plus. The idea here is to be capable of retrieving information from a lot of modelers and then somehow manage the information in a separate program. Okay, here you see that you have the architectural model and then the analytical model of external surfaces, internal surfaces, and edges. No? Here you have a caption of the program. I am going to say that the program is completely free. We are looking for more people to input buildings so we can test how it's working or how it's performing. So the program basically, with what it does, it inputs a geometrical model and it creates an analytical model valid for JSON. This pass between one another can be done automatically, okay? You have an automatic button, yeah, this one, you create your analytical model. But we are aware that there is sometimes a lot of problems with the IFC BIM model. So what we have give also in the tool is a series of tools to correct this model in case that it will be necessary. For example, because somehow a window is really complex and the program has not understand how this window works. So you will have here tools, expert tools, to address these issues in the model and be capable of exporting. Here just some more images of the information that is onto this model. Here more images. You can see here an edge, for example, etc. And again, sorry for being repetitive, but the most important thing for us was that this tool will be for energy experts. They will be capable of generating this model automatically, but they should be also capable of correcting the model in the case that is not well done automatically by our algorithm. That's why we are looking also always to input more models. It's really interesting, your project again, Elena, to see where we can correct this algorithm that we have created. Just finally, I'm just gonna show you the model of one of the buildings. This is the residential building in Victoria. Again, what we did, in this case, they created a really simple model, but it will not be necessary. And then you will have the analytical model that was the one that is going to be inputted in SciPy Ternary Plus. And after that, you have the simulation model, in this case for Spain, in the platform too. I want to say that for us, an analytical model is also a BIM model, but it's another type of BIM model. We have, again, this idea of a building that can be composed not only by a single one source of information or truth, but by a lot of models that will address different parts or different problems regarding the buildings. In this case, we do believe that this analytical model, if it's in an open format, is also BIM, even though it's not inside the IFC, and we should go with that. So thank you very much. And I don't know if there is any question.
That's great, Anne. Thank you for your presentation. We don't have any questions at the moment, but just a reminder to people that if you want to raise some questions on the analytical model that Anne showed us from the BIMSPEED project, then please add them into the comments box. We'll come back to anything that comes in at the end of the next presentation, Anne, but thank you. That was very interesting, really helpful to see the model that is being developed and how you're using it. So thank you. Got another presentation from Anna Moreno now, item 4 on our agenda. So with no little ado, let's go to that now.
I am Anna Moreno, President of the Italian chapter. In my presentation, I will speak about the skills needed for the right exchange of information in openBIM format, the BSI qualification framework, the European ARISE project for the gradual acquisition of competences among all the actors. We have demonstrated in the previous presentations the importance of the information exchange among the different actors of the building refurbishment. The information are necessary to make informed decisions that will influence the operation, maintenance and management costs for the entire life cycle of the building. Through numerous European-funded projects, we have identified the tasks and the related learning outcomes that are fundamental to gather, exchange and store in an open format the information that allow the different experts to perform their work in a correct way. It is important to underline again that the existing condition analysis is the most important phase for the refurbishment of existing buildings. Any euro spent in this phase to obtain reliable information is paid back of at least one order of magnitude during the next stage of the building life cycle, especially during the operation and maintenance. In the next slide, the tasks and the learning outcome for the existing condition analysis have been identified. The requirement for the smooth exchange of information during the lifetime of a building to ensure the best performance has been transformed in a framework of learning outcome to make all the actors aware of the importance of the exchange of the right information among the right actors and at the right time, and above all, in the right format for many possible future use. The first module is related to the existing condition, and the competences are identified from the task they should perform. For instance, the task use the right open standard for collecting relevant information for the building information models will provide the learning outcome identifies standards to be used for documenting existing condition when developing building information models for new or refurbished buildings. To obtain a qualification of BIM and energy performance, a set of 7 questions are associated to each learning outcome. For each question, 4 answers are possible where only one is correct. We have seen in the previous presentation that during the preliminary design, the ESCO or financial institute or owners themselves will make the financial evaluation of the intervention and make informed decision about the refurbishment. Now we describe the competencies needed to collect, exchange and store the correct information in this phase. The same structure used for the existing condition analysis has been conceived for the developed design phase. Here again, the tasks and the related learning outcomes have been identified. The main output of the developed and technical design phases will be a more detailed refurbishment plan that will leave less room to mistakes due to incomprehension or design errors as a consequence of interference between architectural and HVAC plants. This is the exchange process in the developed design phase, and this is the process during the technical design, where all the choices will be frozen so that the financial plan is more reliable and can be used as base for the contract with the constructor. Here again, tasks and learning outcomes are described. These competencies are necessary to ensure that every information is collected, managed, shared and stored in the right open standard and among all the actors responsible for this process. The construction phase is the most challenging, as it is recognized that during the delivery most information is lost, missed or not updated. This is the main reason why the use of a building is considered the most expensive phase. The missing information can cause delay, damage or even disaster. All the problems during the management phase are related to wrong or unavailable information related to the installed equipment and systems. Again, we have identified the tasks and the learning outcomes to ensure the correct management of information during the construction phase and the delivery phase. The operation and management phase is the one where all the advantages for the owner and facility managers are evident, but they will be reached only if all the previous phases have been executed as described. Also for the operation and maintenance phase, the tasks and the learning outcome are identified. In total, the proposed qualification for energy performance and BIM will be based on 5 modules, each with 5-6 learning outcomes. We believe that especially for public buildings and historical buildings, it is essential to ensure that all the actors have the necessary competencies to take all the advantages deriving from the use of BIM. Nowadays, with so many technologies and so many products, we believe that it is important to find a fast but also reliable system to recognize the competencies of the workforce called to make our buildings safer, more comfortable and more energy efficient. The European project ARISE will gather all the existing best practice on education and training in the fields of energy performance and digitalization. ARISE will set up a European platform for the recognition of competencies supported by blockchain technology. ARISE partners have decided to use BSI system for issuing an international qualification. BSI set the rules to develop a learning outcome framework and, through the chapters, recognize the training providers able to qualify people through a web-based qualification system. The experts define the law of and the competencies necessary to get the qualification, and the same expert provide the body of knowledge to be used by the trainees of the registered training providers to train people wishing to be qualified. The system can be used to qualify both workers, professionals, owners, facility managers, etc., that is, all the actors involved in the building process, as we have seen up to now. To conclude, the European project ARISE intends to use the BSI system not only for the BIM competencies but also for the energy performance competencies, as even the best design can be jeopardized by bad implementation of the best available technologies. Any person will be able to access content through any learning platform and will be able to build specific professional competencies little by little through a maturity level system certified through blockchain technology to build a reliable recognition of competencies accepted by the market. The same maturity system will be offered both to the workforce and to the demand side. This because a good offer is built on a good demand. These are my contacts, our website and the RISE project website. We also invite you to participate to the RISE forum with the link here provided. We will select one topic a month to have an open discussion with all the stakeholders. We will take any suggestion to build an international system of recognition of competencies that could be used by anyone from both demand and offer side for the future of our planet without emission coming from our buildings. Thank you to all.
Thank you, Anna. Really interesting to hear about the ARISE project. Thank you very much. I would like to invite our presenters today, so Anna, Elena and Anne, to rejoin us on the screen. You can turn your cameras on and unmute. Yep, that's great. I'm also going to bring Filippo Calcerano in as well, because he is with us. Hello, welcome. Thanks very much for the really excellent and thought-provoking presentations today. There's been some comments that have been raised in the comments area, and we've between us posted hopefully some responses. Starting probably with Anne. Anne, you said in your presentation that the analytical model that you were presenting is available for people to use, I think, and to input their own building information.
Yeah, it's available in BIM Server Center. That is where we have all our tools. It's a free tool right now, and we are quite interested in inputting more complex buildings to see how far the algorithm that we have developed goes and correct the algorithm is if necessary. And yes. You have put also a learning resources page because it's not immediate to use the tool. You have to know how to upload the model and download the model, etc. So I will highly recommend to see that part first.
So people should use this learning link first, so they know what they're doing, and then this is the actual model that they can download themselves. That's great. Thank you for that. And Elena, during your presentation, we had this comment from Stefan. Stefan said, regarding BIM and interoperability, have you looked at the recent study by Oost-Vegel et al.? Digitalization of culturally significant buildings, ensuring high quality data exchanges in the heritage domain using BIM. I think you helped us with this.
The work is interesting, and we would like to deepen the team with the authors, as we're also working on the intelligent semantic enrichment, both to manage stationary and real-time diagnostic data. There's a conservation state report or an IoT net in BEEP project. BIM and BS interoperability problem as the theme of transformation of objects from one software environment to another, which on one hand can be helped by a high-level consolidation of openBIM process. If I have answered to the question, then I just want to notice to Annie that we recognize our very in deep in our heart case study with this Frigento, which we because we have work a lot on this case study with the previous project. It's an Italian project, Magic with stress organization, and that we have dealt with this kind of interoperability problems just in that case study. That I think that could be the starting point for the project. So I'm very happy to see again this interesting case study.
That's great. Thank you, Elena.
Great.
Yes, I think there was some good synergies between.
I didn't know about your project and I saw the connection. Like, okay.
Yeah, that's great. There was some really good synergy between your two projects and the two presentations. So thank you, Anna. Coming to yourself, as we all know, we're kind of in the midst of a worldwide energy crisis at the moment. As energy prices are much higher than they used to be, and supply is difficult. Is that having an impact on this work in terms of building energy efficiency and the way that energy is managed within buildings? Are we seeing more people wishing to improve their energy management, in fact?
Well, I think that all the technologies are there. Only they need to be used in the correct way. But this is not only the point. The other point is that usually the customers, both public and private, do not know what to ask. So the idea behind the activity that we are doing both within buildingSMART qualification and with the DARISE project is to provide the basic knowledge to everybody so that from one side they know what to ask before, and the other side, the people know how to use BIM to make the best use of the actual technologies. So this is our aim, and I apologize that I sent the registration, but I was today in the European project meeting in the RISE project. So now they went for lunch, so I could join you. And it's really interesting because we will provide this European platform for recognizing micro competences in both energy and digital field for anybody, owners, professionals, technicians. Um, so again, I hope that everybody will make good use of the existing technologies because it's not nothing in the future. It's today we can realize our buildings with zero or even positive energy.
That's great. Thank you, Anna. And it's good to hear that the Arise project is happening in real time. And thank you for joining us during the lunch break from the project. From the presentations that we've seen today, and from what you just said, it does appear that there is a lot of activity on this topic, particularly perhaps within Europe. I was wondering if anyone had a view on how the topic is being addressed worldwide, kind of outside of Europe. Are there similar projects and issues being looked at in the Americas and in Asia?
For what I have seen, there were many contacts from United States to our website, so probably they are starting. You know, in especially in United States, it's much easier that you find you pull down a building and you build a new one. But in Europe, we have the problem of our heritage that we cannot just pull down.
Yeah.
So I think that we feel the problem much more than in other countries. But I think that now many other people, many other countries are starting to face this problem because of the climate change. So, but in Europe, it's really there is a really lot of activity because the European Commission has founded hundreds of projects related to this subject.
Yeah, no, understand. That's really helpful to know. Thank you, Anna. We have one final comment from Stefan. I think he was following up with yourself, Elena. Says thank you for your answer, and you're welcome to contact him through
Yes,
through this
we do.
platform or through his LinkedIn, and see whether he can help you on the project or join forces with you on the project. That would be good. Thank you, Stefan. Okay.
May I add something else on the cultural heritage? We are running as BuildingSMART Italy a national working group where both Elena and Philippe are involved that are related to the refurbishment of existing heritage buildings, and we are collecting all the best use cases in Italy, but we are open to collect from any other part of the world to see how BIM has been used to the refurbishment of existing building during all the phase, so design, construction, and the wall management. So if there is anyone interested, please contact me and we can open also to not Italian people.
Yep, that's great. Thank you, Anna. Thank you for adding that. If anyone does want to make contact with Anna and the team who have presented today, then you can find contact details through the BuildingSMART International website. The email address, which you'll also find on that website, is contact@buildingsmart.org. I'm going to bring things to a close because we have no further comments or questions. I'd like to thank our presenters today, Anna, Elena, and Annie, for their excellent presentations, very informative. Thank you for your time. Thank you for Filippo for joining us as well. And look forward to seeing you at further events in our summit this week, later today, and also tomorrow morning. Thank you. Goodbye.
Thank you.
Bye.
Bye. Thank you.